going to start talking now, and people can start listening when they're ready. For those of you I don't know, I'm Rowan. I'm mobile lead at Snapper, and I can just pre-warn you, this talk is not going to be anywhere near as exciting as either of our excellent first talks, but there will be slugs, so at least I should get some points for that, because this is a slug lead up after all. And it will also be quite freeform, so just interrupt me at any point if you have any question whatsoever, or if you want to look at some code. I'm just going to talk about Swift concurrency a little bit, and my journey learning about Swift concurrency. I come from a background of, I'm old, you see, so I got very used to using RX Swift and Combine. You will remember RX Swift, baby days, and been using MVVM architecture for a long time, so kind of interested in looking at how Swift concurrency fits into that picture as a replacement for those tools, RX Swift and Combine. So I'll show you my little demo app that I've got here, and then we'll look at a couple of use cases for it. For those of you who are familiar with Combine, hands up if you've used Combine. Yeah, pretty much, most people, yeah. You'll be used to using cancellables and your escape enclosures and weak self everywhere and needing to manage your references. I'm kind of curious about how we can handle that sort of stuff, like task life cycles in an MVVM and Swift concurrency context. So I'll show you our little setup when it launches. Cool, so there we've got our little slug.
Oh, nice.
And he's turned red, he or she has turned red, which means that it's reproducing. So now we've got two slugs. It's like a slideshow. So slugs are reproducing, and that's all our app does, really. It grows slugs. We've also got this other tab here where we can go to Wikipedia and read all about slugs. So I didn't know this, but slugs, it's not totally out of the question that slugs can reproduce asexually. So that single slug reproducing into multiple slugs, that's not totally inaccurate. But what we'll do is we'll go back to our, oh no, it's hanging. What have I done? Oh, here we go. We'll go back to our slug, and we see that the slugs have just like reproduced out of control. So now we've got a slug problem, basically. So that's kind of happening because we've created a task in our view model, our slug view model here, and it just never ends, you know. It's just spawning slugs forever. And another thing that we can show is I've got a print statement in our deinit here. So our view model, which is just like Dave was alluding to earlier, the observable modifier there, and it's just state on our view. But what we'll see is if we tear down the view, and this just recreates everything from scratch, our deinit was not called, and that's no surprise to anyone because our task here is obviously strongly retaining that view model, and it just never ends, so the view model lives forever. So I was kind of curious if there's a way that we could stop our slugs from reproducing out of control while we're not looking, so that we only see slugs reproducing while we're on that screen. So what can we do? We'll go to part 2. So I'm going to introduce something that we use at Snapper, and it's called Task Scheduler, and that's something we've been using. Oh, I missed a step. Oh well, that's okay, I can just tell you about it. So the other aspect of this is unit tests. So At Snapper, we have quite a strong QA practice. We've got a very good QA lead who keeps us all on our toes, and he loves unit tests. So one thing with unit tests and async code is obviously that you need to await the completion of your async tasks, and if your view model doesn't expose those things, you essentially just end up inserting arbitrary waits in your unit test to wait for the task to finish before you make your assertions. So that was one of the impetus behind this task scheduler thing, was is there a way we can sort of have a single scheduler object that can be used to schedule work, that unit tests can then await the completion of various tasks. But the other idea behind it was this idea of a run context. So the run context is essentially an async scope that you can inject tasks into, or async units of work into, and those units of work will then be coupled to the scope that they're running in. So if you think of the SwiftUI task modifier, that's a modifier that runs a task, and that task is coupled to sort of the SwiftUI view lifecycle. So when that view goes off screen, the task gets cancelled. This kind of gives us a way to couple view model work to that SwiftUI view lifecycle in a sort of simple way. And the way it does it is simply, if we go back to our slugs view, and remember, do stop me at any point if you want to ask any questions. We just have this task that invokes this async method on the view model, and that just awaits this run function on the task scheduler, and it has a callback that just allows you, it lets you know when the run context has been established so that you can start scheduling work. And sorry, I'm just going to check my notes to see what I need. I suppose we should look at how it works, eh? That's the interesting part. So the way it works, the hero of the story is, well, there's two heroes. We've got async stream, which I'm sure everyone is familiar with, and task group, is that what it's called? Yeah, task group. So the way it works is when you call this run function, we create a task, we then have a task group that iterates over this stream that we create, so this run context task stream, and we hold the reference to the continuation so that we can sort of inject tasks into that stream. The type of it is obviously it's just a stream of some async closure that returns void just for convenience. And then anytime that stream emits a task, it just runs in the context of this task group. And so when our run context ends, all of the tasks that are running inside that task group, they get cancelled just like that, so you don't have to worry about manually cancelling them. Where are we? Oh yeah, let's run the app and show that it actually works, huh? Is there another point to make about? Oh yeah, just a note, some interesting tidbits about async stream, I guess, is the continuation is sendable, so you can use it, you can push elements into it from a non-isolated context. So you can use it, for example, you know when you've got a bridge from some old school delegate callbacks that are non-isolated, and you've got to bridge those to your nice async code. Async stream has proven quite useful for that sort of stuff when you need to preserve the order of those events. Because obviously if you just create a task to, say you've got a main actor isolated object that's implementing some non-isolated protocol, as those events come in, and you just create tasks so that you can update your mainnet isolated state, you've got no guarantee that those events will, those tasks will be executed in the same order that they came in. But the async stream can be used to enforce that order because it has some sort of locking mechanism or something that allows it to, basically you can push events into it from any old context. Does that make sense? That was a messy explanation. Cool. Continue on. Did that run? Oh, we got slugs out of control. Okay. We'll clear those slugs, and what we'll do is just check. Yes, so we did de-init our slugs there. We'll go back to the view model just quickly so we can see what's actually changed. We'll see that when we spawn slugs, we'll look at where that's called from. So when we're spawning the slugs, we've added them as a run context task. So it's just an async closure. It strongly captures self, we don't care, that's fine. And it's added as a run context task, and the run context ends when the view goes off screen. So we'll clear it again. We can see that it's de-inited, so that means even though this task runs forever, the view model did get de-inited, so that means the task was cancelled and that reference to self was released. And if we switch to the other screen, leave it for a few seconds so that slugs can spawn or not spawn as they will, and come back, and there's still the same number of slugs, so we know that they weren't reproducing willy-nilly off screen. So that's task scheduler, and we'll quickly jump into our unit tests so that you can see how that looks. Basically, we've got a test here that tests that slugs will reproduce, and previously, I didn't show you this because I forgot, but the way it worked in the first example was we would just sort of sleep for 10 seconds or something and then check that there were some slugs. But here we don't need to do that. We establish our run context just with the async let, and then we just await the next event from the task scheduler. So that's all there is to that.
So is that task scheduler something you share for all of that models, sort of asynchronous queuing? So
Yeah, they all just, but you just have the one task scheduler in the view model, and every async thing that you want to do, you just push into it, and then your unit tests can just listen for those sort of internal milestones inside the view model. It can get a bit chaotic if you have lots of async things going on where you've got to go like next,
yeah.
wait until the fourth thing. Or
certainly beats a bunch of sleep statements, that's for sure.
Yeah, absolutely. I'll just make sure I haven't skipped any important points here. So one thing to note about the way it's implemented is that it relies on cooperative cancellation, where if some async function does not handle cancellation in a particularly graceful way, deleted some code. The way the SwiftUI task, but yeah, we got slugs out of control. The way it works is that obviously the view goes off screen, the task gets cancelled, view comes back on screen, you get a new task. And since that task scheduler instance is the same instance, you need to make sure that the first run context ends, and so that the next one can begin. It can only handle one running at a time. Maybe it doesn't have to, maybe there's a way you could work around that, but for our purposes, that's been fine. But if someone wasn't playing nice in the sort of concurrency, the cooperative cancellation sense, and they were saying, oh, my parent task has been cancelled, I'm just going to keep on doing my thing, I don't care, then that run context can't end because task group has to await all of the child task completion. So it would just keep going, and that would cause bugs.
Did you run into that, or have you found things that like actually long run?
No, I haven't so far.
Okay. That's good.
And I hope I never do.
Yeah.
Cool, so that was that. So what we will move on to now is imagine, I mean, so that works pretty well for when you want to couple your task lifecycle specifically to the view being on screen. But sometimes you want to do something a little bit more lenient, where you want a task that runs specifically for the life cycle of the view model, say. You want one that it will keep reproducing slugs while I'm not on the screen, but it won't prevent the view model from being deinitialized. So if I tear the whole stack down, the view model will be released, as you would expect. So we'll look at some ways that you can do that, and they're not necessarily nice ways, but they will work. Well, this one won't, but anyway. So this example here is sort of what if we just weak the self reference here, and we just say, okay, we're only capturing self weakly. Will this allow our view model to be released when we tear down the stack? So we're not using a run context task anymore. We're using a regular task, so this won't be cancelled when the run context ends. And we're sort of naively going, oh yeah, on deinit, let's cancel this task. And what we will see is if we tear it down, it's not deinitialized. Oh no! And if we stop and think about that for a second, we can see why that is, and it's because this async instance method has to retain self until it returns. And because it never returns unless it's cancelled, it never returns. So it retains self forever. So we can go a little bit more down the rabbit hole if we so choose, and we can sort of say, well, okay, I'll just make it a static method so it doesn't retain self, and then instead you can't pass like weak references as function parameters, but you can pass a closure that returns the instance and then capture that weakly if you really want. So this allows us to completely capture a weak reference to that instance, and it will probably allow our view model to be deinitialized if everything goes well. So we tear it down. I don't know how well that's showing up on the screen, but I pressed the X to make it tear down, and we can see it was deinitialized. So it's like, yay, we got what we wanted. We coupled the life cycle of our task to the life cycle of the view model as far as SwiftUI is concerned. SwiftUI retains the view model. We don't unnaturally extend the life cycle of that object, but it's not going to make us feel particularly nice about any of that, right? Because that's yuck. So what else can we do? I was going to just kind of end it there, but as I was thinking about it, I kind of thought, well, maybe we could use task scheduler a little bit differently. What if we create a run context that corresponds to the life cycle of that SwiftUI state? So how can we do that? Obviously, the view model is the thing that we want to mirror its life cycle, but it's also the thing that our task is naturally going to be retaining. So we're kind of in a chicken egg situation.
Chicken slug, yeah.
Chicken slug.
Slug egg, sorry. Yeah.
Slug egg situation. So what I thought we could try is we could create like a wrapper around our view model. So if we go to our view, we'll see here that instead of having the state be a reference to the view model, we've got this view model holder. And the view model holder is observable in the same way that the view model is, and less than observable actually works really well for that. You can just say, this thing's observable and its property is observable, so any changes to that view model will result in the SwiftUI view being reevaluated. And what we'll do is we'll pass in the view model to it, or rather a closure that returns it. Oh, right, sorry, yes. We pass in a closure that returns it and accepts the task scheduler. So this object creates the task scheduler, and then it injects it into the view model, because obviously the view model needs a reference to the task scheduler to schedule its work. And then it just creates a task, and it says that task is going to run the run context for the task scheduler. And when it's deinitialized, the task will be cancelled. So you can kind of see how this object is now acting as the holder of the run context. It's like a proxy for the life cycle of the view model, because we know the view model is going to be retained for as long as its async work is running. This thing won't be, and it can be used to then cancel that run context. So we can see that our slugs are reproducing here as they do, and then we'll tear everything down, and our slug thing was deinitialized. So we've sort of gotten around that problem of having to do the nasty sort of reference calculus, and we can just write natural sort of self-referencing concurrent Swift code as we like, without needing to worry about any of that, and we just have to we have that proxy that manages the life cycle of the task scheduler. So that was kind of cool. That was like a last minute thing that I thought up. I think there's maybe a better abstraction, like the task scheduler itself. What's missing here is you can no longer do this sort of Swift UI task modifier, because you've already got your run contexts running in the life cycle of the view model, so you can't schedule work that's going to be cancelled when the view goes off screen. So maybe there's a nicer way where you can sort of have some sort of scheduler that can do both of those things, but more work is required. We'll see. I think that was everything. I hope that wasn't too abstract. I thought it would be fun having some slugs to look at least. But, yeah. Any questions?
Conscious of time, but you talked about combining RX and stuff at the start. Like, do you miss like having like some abstraction for like building these beautiful? Maybe I'm showing my hand here. It's still in my combine era, but do you know what I mean? Like in terms of being able to build up these pipelines and.
I did for a little while, but I really I like writing straight, yeah, not nesting things. It's nice, but I know what you mean about sort of chaining things together. There was something nice about that, and combining different streams of things. Yeah,
I get you. Yeah,
but yeah, I'm really quite enamored with the sort of async await syntax at the moment. Yeah. And this was just sort of the cherry on top, where I can have my cake and eat it too. I can write that nice async code and still have the sort of life cycle bound or binding that I wanted.
Nice.
Is this on GitHub?
No, but I'm happy to share it. It's not particularly intellectual property or anything like that. As long as you promise to share any improvements that you make. Cool.